Hi, my name is Chen. I'm here to demonstrate my assignment 1, part 2, CAD1 for the CAD Cam. As we can show in my screen, we will choose the first step, the machine. We will use the G milling machine underscore 3S as our selecting CNC machine because it is located in the UTS campus. Therefore, we can use for the physical operation in there. Then we will choose our stock. For our stock, I just simply click on the top surface of my CAD model. Then they create a box for me automatically. But I will expand the box at both X, Y, Z direction in 2 millimeter because this expansion will allow me to do the cutting for the both top and bottom surface at the beginning. Then after that, I choose my coordinate system at the left top bottom of this point as a datum point, which we will start all the procedure from this point in the later process. Alright, after we set up all the default setting of the CNC machine, we will use two rectangular blocks to hold and lock two sides, like my mouse area, for this stock object. After that, we choose our tool to operate the first procedure. Will be the face milling on the top surface. In here, we choose the face milling procedure, and for the tool, we will set up as the tool fluid HSS and mill as the tool. And the diameter will be 42 millimeter because there is not much restriction for cutting the top surface. Therefore, we use the larger one, which will be make the procedure quicker for the cleaning surface. And the procedure we use is the technology will be the counter. Secondly, we use the same procedure but just flip opposite for the stop object. Then we still use 42 millimeter mill tool fluid HSS. And the depth, yeah, forgot to say just now the first procedure will be 2 millimeter for the top surface cleaning. Then for the bottom, we are doing now is also 2 millimeter for the bottom surface clean. Technology, we use counter. Yep. After we finish the cleaning of both top and the bottom surface, we start the actual features cutting. Alright, then will be the drilling process. In this drilling process, our target is this 6 hole in here. Therefore, we use the tool will be HSS tool fluid drill machine. The diameter will be 20 millimeter, which is according to the size of this 6 hole. And the cutting depth of this tool will be 55 millimeter, and the outside holder will be 80 millimeter, which is long enough to cut this hole. And the level will be from the datum point go through all the hole until the bottom. Therefore, the depth will be 42.822 millimeter. We could simply separate this in 14 steps. Each step will be drilled 3 millimeter approximately to the depth. And this technology, we will use the shortest distance, which will increase the speed for the procedure. and the pass through clear level. All right, then we done for this drilling process. After we have this 6 hole, we could simply remove the 2 rectangular block which hold the stop object at the beginning 2 step. Because we have this 6 hole, we can simply use the slot at the bottom as the holder with the T bolt and nut to fix this 6 hole for this stop. Then this stop could be held stably with the later procedure. After we use the bolt and the nut to fix this stop object, now we use the 3D milling. For this 3D milling procedure, we use the tool will be 2 flute HSS M mill, and the diameter only will be choose 10 mm because we need to cut all the detail inside this circle inside. And I think the closest distance for this 2 rectangular shape will be 10 mm. And also, for simplify the whole procedure, this procedure will cut the outside shape as well. Yeah, because we can just sum all the procedure in one operation, which could be simplified the manufacturing process as soon as better. And the level will be the 32 mm. Probably will be up to this one, the top one of this circle, to the here, the bottom in size, the lower level in here will be 32 mm for the depth. Therefore, in here, we also need to separate the step in around 10 steps. Each step will be around 3.1 mm for the cutting depth. For the technology, we will use the counter. And for this one, because we cut the detail inside the shape and outside the frame, we will have the semi-finish. And the semi-finish, we use the technology will be the linear one, and the wall offsets will be 1 mm. And for the finish, final finish, we will use the circular pocket technology, which will make the light surface more smooth for the inside and outside features. All right, finally, we have these features from here. But for the outside frame, we need to use another 3D milling process. In here, we will use the HS2 flue M mill, but only 2 mm for the diameter, because if you want to cut more detail from the stock to the outside frame, we use this 2 mm for this shorter distance, which can go through entirely on here on the frame, just like my mouse here, to go through up to there to cut. Then we could have the final outside frame, but for this level will be from -27 to -42, because remember on the last step we cut some part of the outside frame as well, according to the last step. Therefore, we just need to cut the rest of the outside frames to the bottom base. And the technology we will use is still counter, which I think will be better to finish in the CNC machine. And the semi-finish we use linear. The final finish we use the linear as well, because outside frame linear will be the better finish according to my research. And then done. This is the whole process. And I will calculate all to show the general step in total. Moreover, I will run the 3D simulation to show I'm doing the correct step. And of course, I want to use the fastest way because the time of the video is limited by the time as well. So I will show on the faster speed. Yeah. It's cutting step by step. It's cutting the inside features with 3D milling up to this process. Yeah, and I think almost pretty much we like this, and I don't want to make my video too long to make you feel bored. So I will finish now for my recording for the part 1 CAD1.